Hi, my name is David Jensen, and today I'm going to be talking about LabVIEW Homework 3 for electronic instrumentation. So the goal of this assignment was to create an interface which will have a counter which will remain at 0 until a toggle button is pressed and released, at which case the counter will begin to increase in an increment of 5 per second until the toggle button is pressed again, at which point the counter will begin to count down at a rate of 2 per second until the toggle button is pressed again, at which point it will toggle back and forth between counting up by 5 and counting down by 2. If the counter is allowed to run down to 0, the program will latch the count at 0 and it will remain there until the toggle button is interacted with again. An important note here is the mechanical action of this toggle button. It's on switch until released. And so that's an important element of getting this program to function properly here. So on the right here, we have our front panel, which is pretty simple. It's basically just a toggle button, a count indicator, and our stop button. This will be what the user interacts with. And then on the left here, we have our block diagram, which is where all of the logic and computations occur. So the block diagram consists of a while loop with a nested event structure. And then inside of the event structure, there is a nested case structure. Each event will have its own nested case structure, and each case structure will have two cases within it. So starting out with the toggle event, this event is going to be responsible for switching the mode from counting up to counting down. And this is achieved by shift registers and some basic Boolean logic here. So starting with the numeric shift indicator, it's initialized with 0 so that when the program is first started, it will default to 0. And this is just fed straight through our case structure and event structure into our count and our shift register to be recycled with each iteration. The Boolean shift register is initialized with false, which keeps the program from starting to run until the toggle button is pressed and released. And this Boolean input is fed through the event structure into the case structure, through a not block in the false case, and then back to the shift register. So the toggle event is tied to the toggle button. And so this event will execute whenever the toggle button is pressed. Now, to get the action that we're looking for in this assignment, the mode needs to not switch until the button is pressed and released. So the way this was achieved was, again, when the button is pressed, this event will trigger. And while holding that button down, this new value will be true. As soon as the toggle button is released, new value will go to false. And so that is triggering this case structure so that as soon as it goes to false, it will trigger the false case here, and the not block will flip the logic from true to false or false to true, depending on the input. The true case here, again, is just fed straight through. It doesn't do anything, so that whenever the toggle button is held down, nothing is changing. Moving over to the timeout case event. This is triggered by this 1,000 constant, 1,000 milliseconds. So this essentially just means that every 1,000 milliseconds or 1 second, this timeout event will run, and it will continue to run every 1,000 milliseconds unless the toggle event is triggered. So this event is going to be where all of the counting logic occurs. So the case structure inside of this is triggered by the Boolean, which the Boolean is flipped true or false by the toggle structure. So whichever input we have feeding into here will determine the case that's being executed, and it will also feed straight through to the other shift register to continue being recycled with each iteration. The numeric shift register will provide its input through the event case, event structure, into the case structure, and in the true case, it will take that input and add 5 and feed it to the count indicator as well as the shift register to be recycled. And in the false case, it will take this input, it will subtract 2 from it, and then it will evaluate it to whether or not it is less than or equal to 0. If the value is greater than 0, it will feed the output of this expression through the select block and then to the shift register and indicator. If the evaluation of this value is less than or equal to 0, it will select this 0 constant and feed that through to the shift register and indicator, which will effectively latch the count to 0 and will continue recycling that 0 for every iteration until the toggle button is pressed and released again. Our toggle button down here is tied here to the front panel, and again, it triggers the event here when it's pressed. The stop button is just responsible for stopping execution of the program whenever the user presses the stop button on the front panel. So we'll give a quick demonstration of how this operates. So once the program is running, everything will remain in an idle state here. The count will remain at 0, and nothing will be changing here. And this will remain this way until the toggle button is pressed and released. So we can show if it's pressed and just held, nothing will change. But the second it is released, we begin to count up by 5 until it's pressed and released again. And that will trigger it to count down by an increment of 2. That downward count will continue until reaching 0, and it will latch there and remain there until the toggle button is pressed again. So if we toggle it again, let it count up, then toggle it once more, it'll start counting down. Press and release one more time, it'll count up, press and release, down. And so you can continue that as many times as you want to until again it reaches 0, in which case it'll stop. We can stop the program executing using the stop button shown there, and also the program will reset to a default value of 0 each time it's executed. So it's stopped, it's still showing a value of 35 here, but as soon as you run the program again, it'll reinitialize to 0 and wait in this idle state until the toggle button's pressed. So that covers the assignment homework 3 for electronic instrumentation. Thank you for watching.